today's class. So, as we progress, other people are going to join. So, we'll carry them along as well. All right. So, first
Okay.
things first, before we begin the class, let me start by throwing the question open. When those three words are mentioned, mixtures, elements, and compounds, what comes to your mind? Can you tell me?
Yes, sir.
Yes.
Element is like the element is a substance that is formed from two or more atoms that are chemically combined.
Elements.
Is a substance that is formed.
I'm listening.
Element is a substance that is formed from two or more atoms chemically combined.
Two or more. Oh, okay. I've heard your definition, but your definition can use a lot of help. Okay.
Then
But
compound is formed from two or more elements chemically combined together.
okay, how about mixtures?
A mixture is the combination of two or more elements or compounds that is not chemically combined, chemically
Hmm.
bonded.
Okay. All right. So we're going to be looking at all of them individually, okay? I just wanted to test out your basic knowledge of all these three things. So here is the lesson outline, all the things that we're going to be doing in today's class. Number one, we're going to be seeing what mixture is, because among the three words, mixtures, elements, and compounds, mixtures come first. So we're going to be seeing what mixtures are. We're going to be seeing the types of mixtures based on the particle size. Are you ready for today's class?
Yes, sir.
All right, beautiful. So first things first, think about one mixture that you have made at home, like your favorite drink. Can you see this drink that I have on the screen right now?
Yes, sir.
What's your favorite drink, by the way?
Uh, I like Coke.
You like Coke? If I ask
Yes,
you to
sir.
make Coke, can you make it?
Not really, sir.
You
Maybe my
cannot,
ingredient.
not really. You can't make it. Do you have the ingredients?
Yeah, I don't have the ingredient. If I have the ingredient, I ask someone to teach me.
All right. Um, what's your favorite drink that you can make by yourself if they give you the ingredients?
Maybe smoothie.
Okay, smoothie, beautiful. And that's what is on the screen right now, by the way. It's a smoothie. So now you would agree with me that this smoothie is not just made up of one substance. There were different things, one, two, three, and so on and so forth, that were combined together in order to make this smoothie. Is that correct?
Yes, sir.
Good. So those things that were combined together are called ingredients, or whatever it is, whatever name you want to call them. And again, there is a process that has to happen before this smoothie can be produced. You need to stir those things together. Is that also correct?
Yes, sir.
Good. So that brings us to the concept of what mixtures are. A mixture, we're going to be learning what it is. We're going to be differentiating between the types of mixtures, which, by the way, are homogeneous and heterogeneous mixture. And then we are going to be seeing different categories. So let's start off by defining what a mixture is. A mixture is composed of two or more substances. Can you see what's on the screen?
Yes, sir.
Good. That are combined, yet they can still be separated into the original parts. So, based on that definition, we have two different kinds of mixtures. We have the homogeneous and then we have the heterogeneous. Are you with me?
Yes, sir.
Beautiful. So, for the homogeneous mixtures are mixtures that have uniform composition all throughout. That is, for instance, now, if I have a cup like this, and then that cup is filled with a mixture, throughout the entire container, every point is the same. So a very good example is lemonade. Do you know what lemonade is?
Yes, sir.
Beautiful. And you know that lemonade is not just made of one substance. Is that correct?
Yes, sir.
There are different things that are combined together in order to make lemonade. But when you look at lemonade at first glance, there is just one uniform color all throughout the entire cup. Is that correct?
Yes, sir.
Good. That's a homogeneous mixture. It has a uniform composition all throughout. Throughout the structure, the composition is the same. So coming to the heterogeneous kind of mixtures, the heterogeneous mixture is a kind of mixture that has a varying composition. Do you know the meaning of this word varying?
Yes, sir.
What?
Different.
Thank you very much. That means it is different. It changes as time goes on. So here is a very good example of an heterogeneous mixture, meat and vegetable stew. I'm sure you know vegetable stew.
Yes, sir.
How won't you know it? All right.
Mm.
You know that the composition of vegetable stew at one point, point A, might be different at point B. Here is what I mean. You can see over here, this is lap of a chicken. Is that correct?
Yes, sir.
And then over here is something else that is different. Is that correct?
Yes, sir.
Good. So even though this is also a mixture, there are different substances or different compositions at different points in the mixture. Unlike this lemonade, every point in the mixture was the same. But here in the vegetable stew or the vegetable soup rather, we saw that the composition changed at different points in the mixture. Do you have any questions?
No question, sir.
All right, beautiful. So I want you to see what's on the screen. Can you read out what you can see for me?
Yes, sir.
Okay.
Rubbing alcohol,
Mm-hmm.
milk,
Mm-hmm.
muddy water.
Beautiful. What are the differences between these mixtures that you can see on the screen right now?
Mm, maybe the difference in color.
Okay. Apart from color, what else?
Maybe how it is formed.
How it is formed. Okay. All the things you mentioned are correct. Now, one big difference between the three of them is what is on the screen right now. Some particles are visible and some are not. Do you agree with this statement?
Mm, I think so, but I'm
Yes.
a bit confused.
Okay, good. If you take muddy water, for instance, this is muddy water over here, right?
Yes, sir.
Good. If you take a very close look at muddy water through a transparent glass, you can see some of the particles of mud flowing in the water or floating inside the water. Is that correct?
Yes, sir.
Good. Rubbing alcohol, on the other hand, if you look at it through an invisible glass, in fact, you might not even be able to see anything. In fact, at the first glance, you might think maybe it's ordinary water because it is absolutely colorless. Have you seen rubbing alcohol in real life before?
No, sir.
Is that thing that you people call spirit? You know
Oh,
spirit?
yes, sir.
Yes, that's
Methylated
rubbing.
spirit.
Yeah, methylated spirits. When somebody gets injured and then they are trying to clean the wound. So
So,
we call it rubbing, we also call it rubbing alcohol. If you're looking at it through a transparent glass, can you see any particle inside?
no, sir.
Of course not. You can't see any particle. However, in the case of muddy water, if you look at it through a transparent glass, you are able to see some particles. And that's why we're moving into the types of mixtures according to particle size. Are you there? So
Yes,
we
sir.
have the first one, solution. Say after me, solution.
Solution.
Good. So under the types of mixtures, we have the first category, which is called a solution. A solution is a homogeneous mixture. You remember what we said a homogeneous mixture is, right?
Yes, sir.
Good. What's a homogeneous mixture?
A homogeneous. Some common.
I hope you're taking notes now.
Yes, I'm taking notes down,
Oh,
sir.
beautiful. So what's a homogeneous mixture?
A homogeneous mixture is a mixture that has a uniform composition all around.
Good. Good. Uniform composition. That is, the composition does not change at any point in the mixture. So, a solution is a homogeneous mixture that has a particle size of 0.01, between 0.01 to 1. Do you know the meaning of this nm over here? Do you know what it means?
Yes, sir.
Okay,
Nanometer.
thank you. That's a unit of measurement, nanometer. Now, the particle sizes are so small that you cannot see them with your naked eyes, and they cannot be separated by filtration. In other words, if you carry a sieve or a filter paper, you know what a filter paper is, right?
Yes, sir.
Of course, you must have seen one in the chemistry laboratory. So you take a filter paper, any sort of filtration device you can lay your hands on, whichever one you pick, they will not be able to separate the particles that make up a solution. So that's why it's called a solution. Characteristic number one, it is a homogeneous mixture. In other words, it has a uniform composition throughout its structure. Characteristic number two is that the particle size is between 0.01 to 1 nanometers. And then the third is that it cannot be separated by filtration. Here are some examples. Example number one, what is it? What's example number one?
Iced tea.
Iced tea. Good. How about example number two?
Rubbing alcohol.
Also called methylated spirits. You remember that, right?
Yes, sir.
Good. And then the third example is called
Salt dissolved in water.
beautiful. Beautiful. I'm enjoying how you're following every bit of today's class. So that is an example of a solution. Each and every one of these examples cannot be separated by filtration. So the next type of mixture that we have is called the colloid. Can you say that after me?
The colloid.
Good. Have you heard this word before?
I've heard of it before.
Okay. Did you ever stumble across any explanation as to what it means?
Not really, sir.
Okay, so let's explain what it means now. A colloid is a heterogeneous mixture. Of course, you know what a heterogeneous mixture by now is, right?
Yes, sir.
Good. A heterogeneous mixture is one that has a varying composition throughout its structure. So a colloid is a heterogeneous mixture with a particle size that is ranging between 1 to 1,000 nanometers. Now, particles do not separate on standing. Do you know the meaning of this statement?
Yes, sir.
What does it mean?
Like it doesn't fall apart maybe like when it's standing or together.
Okay, what we mean, yeah, and the first part of that explanation you gave is correct. It doesn't fall apart or separate when it is left undisturbed. For instance, if you take a bottle of milk and you shake it, shake it, shake it, shake it, shake it, shake it. And after a while, you keep the bottle of milk on the table. The particles inside that milk will not separate just because you left it undisturbed. Is that correct?
Yes, sir.
However, if you take a bottle that is mixed with sand and water and you shake it, shake it, shake it, and then you keep it on the table undisturbed, what will happen after a while?
Mm, to fall apart.
The sand will settle down. Is that correct?
Yes, sir.
And then the water will remain up. So that's just to illustrate what this statement means. Particles do not separate on standing. That is, when you keep a container of a colloid, the particles will not separate because you left it undisturbed. So here are some examples. Example number one is, can you see what's on the screen?
Yes, sir.
What's it?
Mayonnaise.
Mayonnaise. Do you know what mayonnaise is?
Yes, sir.
What's mayonnaise?
It's and like I don't know, me it's like something I wish to eat with bread.
Something that we used to eat with bread. Oh my God. All right. Speaking about something that we used to eat with bread, another example of a colloid is called,
Milk.
I just wrote it on the screen right now.
Oh, butter.
Yes, butter is another example. Mayonnaise is one example. Another example is milk. And another example is gelatin. We call this actually jelly over here in Nigeria. All right, so that's the second example. Thus far, so far, and so good. Do you have any questions to ask?
No, sir.
Okay, any confusion?
Not really, sir.
They not really had me concerned though. Where is your confusion? Let me know.
I don't have much confusion. But
Yeah, I'm listening. I'm listening. I'm listening. Let me hear where your confusion is.
hello?
Yeah, I'm with you. Did you have a network glitch?
Hello?
Yeah, I'm with you.
I said I don't really understand that colloid.
Okay, let's take it one more time. So a colloid is a heterogeneous mixture. Are you there?
Yes, sir.
Good. Heterogeneous means that the composition is not the same throughout. Now, why did we say it is heterogeneous? Have you come across, for instance, let's say maybe a can of mayonnaise or a bottle of milk or a can of jelly, where possibly as you were eating it, you came across some lumps that are contained inside. Have you come across something like that before?
What is that? So what no lumps?
Lumps, like those small balls that you come across when you're taking maybe butter or milk
Oh, yes, sir.
of, yeah, of stuff that have coagulated over time.
Yes, sir.
Good. That is telling you that the structure or the composition of that mixture is not the same throughout. Unlike the other examples that we saw of solution, the iced tea, rubbing alcohol, and salt dissolved in water. In this case, this is a heterogeneous mixture, and the particle size ranges from between 1 to 1000 nanometers. And then the third characteristic is that the particles do not separate on standing. I think I need to add something to this. Standing here simply means when left undisturbed. Are you with me?
Yes, sir.
Good. And then finally, it cannot be separated by filtration. What we mean is that the particles or the substances that make up the colloid, you do not separate them by filtering them. For instance, you take mayonnaise and you're trying to use a filter paper or a sieve, whatever it is you can lay your hand on. The particles will not be separated successfully. Is that correct?
Yes, sir.
Good. Is your confusion clear now?
Yes, sir.
All right. So the third example of mixtures based on particle size that we're looking at is what we call the suspension. Can you repeat after me? Suspension.
Suspension.
Beautiful. So the suspension is a heterogeneous mixture as well. And in this case, the particles are large enough to settle. You remember when I told you about the example of a bottle containing water and sand, right?
Yes.
So if you have the water over here and then you shake the bottle of water and sand, after a while, you will see the sand settling down at the bottom of the bottle, just like I drew over here. Are you with me?
Yes, sir.
So the name given to this kind of mixture is called a suspension. Why? Number one, it is heterogeneous. The composition of the mixture is not the same throughout. Some parts are made of water and some parts are made up of sand. You can see the difference just by looking at it. And then the particle size is over 1000 nanometers. So any kind of mixture that the particle size is over 1000 nanometers, we call it a suspension. And then in this case, the particles are large enough to settle, or they can be seen with your naked eyes. And then they can also be separated by filtration. Can you see the examples on the screen?
Yes, sir.
Beautiful. Example number one is what?
Muddy water.
Beautiful. Example number two.
Kimchi
Beautiful. Do you know what kimchi is?
in vinegar.
Do you know what kimchi is?
Mm, no, sir.
Okay, kimchi in vinegar is a mixture that is used in the kitchen by women who cook. But you might not really find the application here in Nigeria. Is overseas kind of stuff. Okay.
Yes,
But
sir.
in this case, you can see that the mixture, you can see the particles that are inside, right?
Yes, sir.
And then final example that you have is salad dressing. Can you see them all?
Yes, sir.
At this point now, I want you to mention for me what other examples of suspension do you know? Yes.
Maybe salt dissolving in water.
Suspension, oh, the ones that you can see the particles with your normal eyes. Suspension, oh, yes. Yes. Dominic.
Hello, sir.
Yes, I'm with you. I never left.
Maybe paint.
Paint. Now, before you mention any example, ask yourself, can the particles be separated by filtration?
Mm, maybe. I don't think so.
Yeah, you're right. You don't think
Eh,
so?
maybe flour in water.
Flour in water, flour in water.
Wow.
If the flour has not dissolved, yes, but if the flour has dissolved in water, you may not be able to separate it by filtration. How about stone in water?
I think so. Hello.
Yeah, I'm with you. Stone in water is a good example. Give me another example.
I don't know much examples.
Now, I want you to give me one before. I want you to be at least able to mention, even though it's one.
Yes, let me think.
Yes, it doesn't have to be water plus something, though. Something that you can see the different parts of the mixture.
Okay, sir. Um, charcoal in water.
Thank you very much. Charcoal in water is a very good example. What other one do you know?
Yeah, I don't know much. I think that's all.
Okay, at least you tried. You mentioned one. That's beautiful. So, let's review what we've been talking about. Can you see what's on the screen right now?
Yes, sir.
Beautiful. Let's read it. Can you read that for me?
Yes, sir.
All right, go ahead.
Mixture mixture is two or more substances combined, yet can still be separated into the original parts.
Yes, beautiful.
It can be homogeneous or heterogeneous. Types
Mm-hmm.
of mixture: solution, colloid, suspension. Solution: particle size between 0.01 to 1 nanometer.
Mm-hmm.
Colloid: particle size between 1 to 1000 nanometer.
Mm-hmm.
Suspension: particle size greater than 1000 nanometer.
Beautiful, beautiful. Absolutely beautiful. So now that we have seen what mixtures are, the remaining two we want to look at are elements and compounds. Can we go into that now?
Yes, sir.
Beautiful. So before we do that, we need to talk about what matter is because these stuffs that we want to talk about, which are elements and compounds, they are the ones that make up matter. So we're going to talk about the properties of matter. We'll talk about atoms, elements, molecules, and compounds, and see some more examples of mixtures. So on the screen right now, I have the definition of matter, and it is anything that has mass. We used to say weight in elementary science, but now we have redefined it to mean mass, anything that has mass and takes up space. Are you with me?
Yes, sir.
Good. So here are some examples of matter. You are made up of matter because you have mass and you occupy space. Water is made up of matter. It has mass and it occupies space. The balloon that has air inside is a form of matter because it has mass and it occupies space. What else is made of matter? Give me an example that you know. At least two examples.
A wood,
Wood, okay. What else?
metal.
Wood and metal. Beautiful. All these things have mass and they occupy space. So now that we
Okay.
know what matter is, here are some properties of matter. Matter has some properties that can be measured. Examples of them are color, shape, size, texture, density, and the state that it exists in. Under the states that it exists in, we have the solid, the liquid, and the gas. We've talked about this in our previous class. Is that correct?
Yes, sir.
Beautiful. So now that we know what it is, let's now talk about elements. We started off this class by asking you what element means. Okay. So now here is what an element is. Here is the definition. An element is a pure substance. Any definition that doesn't include this word pure, trash it. Okay.
Okay, sir.
Good. An element is a pure substance made up of only one type of atom. A pure substance that is made up of only one type of atom. Remember, we talked about what an atom is. The smallest part of a substance that retains the chemical properties of that substance and can take part in a chemical reaction. Do you remember that?
Yes, sir.
Good. So now, under the periodic table, there are over
Yes, sir.
a hundred known elements that we have. Each of them having their
Yes, sir.
each of them having their unique properties. For example, what is the name of these elements that I just labeled?
So which one?
This one I just labeled.
Maybe
Should I
chlorine.
label it? Should I label it again?
So is it the Mn?
I just labeled it now. Can you see the labeling that I'm doing?
Okay. Yes, sir. I can see it now.
What's the name of the element?
I think it should be chlorine. Mm,
Chlorine. No, chlorine is Cl. This is Cr.
what's it? Yeah, I don't know. I don't really know it, sir.
Okay. This is called, can you say it?
Aluminium.
Not chromium or chromium.
Chromium.
Chromium. Chromium.
Oh, chromium.
Yeah. So how about this one that I labeled just now? What is the name of this element?
That's carbon.
Thank you very much. Carbon with the letter C. So now what we're simply saying is that elements are pure substances made up of only one type of atom. So the similarity between all of these guys is that they are made up of just one type of atom, and that is why they are called pure substance. Once something is not made up of only one type of atom, we cannot say it is a pure element anymore. So now that we know what an element is, here is the definition of what a compound is. A compound is a pure substance made up of two or more different elements that are chemically joined together. Are you with me?
Yes, sir.
Good. In the case of a mixture, the difference between a compound and a mixture is that in the case of a mixture, the components are joined together physically. But in the case of a compound, the components are joined together chemically. Are you there?
Yes, sir.
Good. So here are some examples of compounds that we have. Sodium chloride. In the case of sodium chloride, how many elements do we have here?
Two, sir.
Good. Which one and which one?
And sodium and chloride. That's for
Okay.
table salt.
Thank you very much. Sodium and chloride for table salt. And then the normal sugar that you take when you want to drink garri or take tea, this is the molecular formula for it. Do you know the chemical name for this?
Yes, sir.
What's name?
Oxygen.
Eh? No, no, no. I'm not talking about the element. I'm talking about the chemical name for sugar.
And that is 12 carbon. Okay, sucrose.
Do you know what it is now?
Yes, sir.
So if someone stops you on the way and asks you, I'm Dominic, let's know what the chemical name for sugar is. What would you mention it to be?
Sucrose.
Okay. Okay, good, 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 good. Beautiful. So I'm glad you're following every bit of today's class. So we've talked about what elements are. We've talked about what mixtures are. We've talked about what compounds are. Now I want you to help me out. Define the three of them in a way that you understand. Let me hear you out. Elements, compounds, and mixtures. Go ahead.
Element is element is a pure substance that contains only one atom.
Okay. Okay. One type of atom. Beautiful.
Mixture is a substance um, that is formed from the combination of two or more substances that can still like can still get the original form back.
Okay. You can still separate the components back. I
It can
get
that
you.
can still be separated.
Mm-hmm. Mm-hmm. Mm-hmm.
Then
Mm-hmm.
compound is a pure substance that is made up of two or more elements that are chemically combined.
Mm-hmm. 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 Beautiful. You have defined the three of them in a way I absolutely love. So we've talked about them. Now let's go over the concept of mixtures again. A mixture is a combination of two or more substances that are not chemically bonded together. Example of these are salt water and air. Did you know that air is a mixture?
Yes, sir.
Wow, beautiful, beautiful. I'm excited that you know this. Air is actually a mixture. And we talked about the types of mixture. We talked about solutions. Now, here is another different definition for solution that you might want to pay attention to. Trust me, this one will help you out. A solution is a type of mixture in which one substance is dissolved in another. Do you know what it means for something to dissolve?
Yes, sir.
Good. What does it mean?
Like breakdown, I mean.
Okay. Breakdown. I like that word that you used. For instance, if you put salt in a cup of water, what happens to the salt?
It dissolves, sir.
Good, good. Now you know what dissolve is. So a solution is that type of mixture in which a substance is dissolved in another substance. So that substance that is dissolved is called a solute. And then the substance that does the dissolving is called a solvent. So for example, now, if I put some salt in water, I have a solution called salt water. Is that correct?
Yes, sir.
Beautiful. So what we are saying is that the substance that gets dissolved, this salt, it is called the solute. And then the substance that does the dissolving, water, is called the solvent. Now, let me ask you this question. If I have, let's say, a solution of sugar and milk
Hello,
together.
sir.
Yes,
Sir,
can you hear me?
your line is breaking.
Oh, can you hear me now?
Hello, sir.
Hello, can you hear me now? Can you hear me now?
Yes, sir. I think I had a network glitch.
Okay, can you hear me now?
Yes, sir.
Okay, beautiful. So what I was saying is, if I have a solution now of sugar and milk, I want you to tell me which one is the solute and which one is the solvent.
Sugar is the solute and milk is the solvent.
Beautiful, because sugar is the one that gets dissolved. Milk is the one that does the dissolving. Beautiful, 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 beautiful. So here are some
No.
examples of solutions. We have sugar dissolved in water and salt dissolved in water. We've seen what colloids are, and then we've also seen what a suspension is as well. So with that, we've come to the end of today's class. We've seen what mixtures are, we've seen what elements are, and we've seen what compounds are as well. Do you have any question at this point?
No question, sir.
Are you sure?
Yes, sir.
Beautiful. So we've come to the end of today's class where we saw the meaning of mixtures, elements, and suspensions. Can I give you an assignment?
Yes, sir.
All right, so I'll drop the link for the assignments in the group. I'd like you to go ahead, give them a try. And once you submit them, I'll be notified and you'll be graded on the spot, okay?
Okay, sir. Sir, but last time when I didn't see any link for the assignment the last time.
Oh, really? Are you on the SS1 group?
Yes, sir. I didn't see any link.
Okay, I'm going to
I only
re-verify.
saw a playground something
Playground. Is he
like
way
a web.
way ground? Yeah, that was the link for the
Yes, sir.
assignment. Did you click the link?
Yeah, I clicked it, sir,
What page did it take you to?
and it took me to alkaline where we have ethanol, methanol, butan,
Was it on the
propan.
SS1 group I posted it?
Yes, sir.
Oh, that was a mistake on my end. It was not meant for you guys. Don't worry, I'll post the link for today's assignment on the SS1 group, okay?
Okay, sir.
All right, I look forward to seeing your trial for the assignment. Thank you very much.
Okay,
I'll
sir.
see you in the next
So, and
class.
the last assignment,
Yes.
I snapped it and sent it to your DM.
Okay. Send it again.
Okay, sir.
All right, I'll be expecting it, all right?
Okay, sir.
All right, bye for now.
Bye, sir.